A triangle is inscribed in a circle. The vertices of the triangle divide the circle into three arcs of lengths 3, 4, and 5. Then find the vertex angles and the area of the triangle. Let O be the center of the circle and ABC are the vertices of the triangle. O is the center and A, B, C are the three vertices of the triangle ABC. Let arcs, this arc AB, BC and CA have lengths of 5, 4 and 3 respectively. AO, BO and CO, that is this and this are three radii of the circle. Let us call them capital R. Then the circumference of this circle is 2 pi r, which is nothing but the sum of the three arcs 5 plus 4 plus 3. Therefore, 2 pi r is equal to 3 plus 4 plus 5 is equal to 12, which is 2 pi r. Therefore, r is equal to 12 divided by 2 pi is equal to 6 by pi. The angles subtended by the arcs at the center O will be in the ratio of the arc lengths. That means this arc, which is smaller, will subtend a smaller angle at the center. This arc, which is larger, will subtend a larger angle at the center, and this arc, which is the largest, will subtend the largest angle at the center, this angle. And these three angles will be proportionate to their arc lengths. Since the sum of the three central angles, that is this angle plus this angle plus this angle, is 2 pi, angle AOB will be 5 by 12 multiplied by 2 pi. That is, this angle will be 5 divided by the circumference, which is 12 multiplied by 2 pi, which is 5 by 6 pi, that is equal to 150 degree. This angle is 150 degree. Similarly, angle BOC, this angle will be, this arc length is 4 divided by the circumference, which is 12 multiplied by 2 pi, which is 2/3 of pi, that is 120 degrees. The third angle COB, therefore, will be, arc length is 3 divided by the circumference, which is 12 multiplied by 2 pi is equal to half pi or 90 degrees. The angles subtended by the arcs at the circumference of the circle are half of the angles subtended by them at the center of the circle. Let us take this arc. It subtends angle 90 degree at the center, this angle. Therefore, it will subtend half of that angle, that is 45 degree, at the circumference. Using this principle, angle at C, this angle will be half of this angle, because this arc subtends angle 150 degree at the center, so the same arc will subtend half of 150 degree, that is 75 degree, at the circumference. So angle C will be 75 degree. Similarly, angle at A will be half of this angle, because this arc subtends this angle at the center, which is 120 degree. Therefore, this arc will subtend half of 120 degree, that is 60 degree, at the center. So angle A will be 60 degree. Similarly, angle B, that is this angle, which is subtended by this arc, will be half of its central angle 90. Therefore, this angle will be 45 degree. So angle B will be 45 degrees. From the law of sines, which states that in a triangle with sides of A, B, and C, and the corresponding opposite angles A, B, and C, A divided by sine A is equal to B divided by sine B is equal to C divided by sine C is equal to 2R, where R is the radius of the circle on which the vertices A, B, and C lie. So we get, in this case, AC divided by sine angle ABC is equal to BC divided by sine angle CAB is equal to AB divided by sine angle ACB, which is 2 multiplied by 6 by pi, which is equal to 12 by pi. Let us call it equation 1. If you get confused about the figure, please go back and look at the diagram to understand this. We know that angle ABC is equal to sine 45 degree, which is 1 by root 2. Similarly, sine CAB is equal to sine 60 degree is equal to root 3 by 2. And sine ACB is equal to sine of 75 degree, which is sine of 45 degrees plus 30 degree. And if we expand this term, it becomes sine 45 degree multiplied by cos 30 degree plus cos 45 degree multiplied by sine 30 degree, and putting their values, this cos 45 is also 1 by root 2, sine 30 is root 3 by 2. So by simplifying this, we get this is equal to root 3 plus 1 divided by 2 root 2. That means sine ACB, which is sine 75 degree, is root 3 plus 1 divided by 2 multiplied by square root of 2. Hence, using equation 1, we get AC is equal to 12 divided by pi multiplied by 1 by root 2. Remember, we have seen in equation 1, which is this, AC divided by sine of angle ABC is equal to BC divided by sine of angle CAB is equal to AB divided by sine of angle ACB is equal to 12 by pi. So we are putting the values of AC, which is 12 by pi, which is 12 by pi multiplied by 1 by root 2, and that is 6 root 2 divided by pi, that is B. Similarly, BC is equal to 12 by pi multiplied by root 3 by 2, which is 6 root 3 by pi, and that is equal to A. And AB is equal to 12 by pi multiplied by root 3 plus 1 divided by 2 root 2, and if we cancel out 2 root 2 from 12, we get 3 root 2 here remaining. So that works out to 3 root 2 multiplied by root 3 plus 1 divided by pi, and that is side C. We had earlier found that angle A is equal to 60, angle B is equal to 45, and angle C is equal to 75. Once we have found out the three sides of the triangle and its three angles, we can find out its area by using the formula area is equal to half multiplied by A multiplied by C multiplied by sine B, where A and C are two sides and B is the angle included by these two sides. In this case, A is equal to side BC, which is 6 root 3 divided by pi. C is equal to side AB, which is 3 root 2 multiplied by root 3 plus 1 divided by pi, and B is equal to 45 degree. So sine B is equal to sine 45 degree, which is 1 by root 2. Therefore, area is equal to half multiplied by A, which is this, multiplied by C, which is this, multiplied by sine B, which is this. Here, this root 2 will cancel out with root 2, then 2 will cancel with 6, giving 3. So in the numerator, we have 3 multiplied by 3 multiplied by root 3, which is 9 root 3, whole multiplied by root 3 plus 1. And in the denominator, we have pi multiplied by pi, which is pi squared. Now if you take this root 3 into the parenthesis, we get area is equal to 9 divided by pi square multiplied by root 3 into root 3 is equal to 3. Root 3 multiplied by 1 is equal to square root of 3. So you get area is equal to 9 by pi square multiplied by 3 plus square root of 3. There are many other formulae we can use to find the area of the triangle. For example, another formula is area is equal to ABC divided by 4R, where A, B, C are the three sides of the triangle and R is the radius of the circle on which the vertices of the triangle are located. In this case, A is equal to 6 root 3 by pi, B is equal to 6 root 2 by pi, and C is equal to 3 root 2 multiplied by root 3 plus 1 divided by pi, and R is equal to 6 by pi. We have found out all these values earlier. Therefore, area will be, this is A, this is B, this is C, and this is 1 by R, and this is 1 by 4. Hence, we get area is equal to, after cancelling out many terms, like this will cancel out with this will cancel out with this. So you get area is equal to square root of 3 multiplied by 6 root 2 multiplied by 3 root 2 multiplied by square root of 3 plus 1 divided by 4 pi square, which is 36 multiplied by square root of 3 multiplied by square root of 3 plus 1 divided by 4 pi square is equal to 9 pi square multiplied by 3 plus square root of 3. So the vertex angles of the triangle are 45 degree, 60 degree and 70 degree, and its area is 9 divided by pi square multiplied by 3 plus square root of 3. This is the answer. Thank you.